Hey there, ready to dive into some seriously big
Oh,
questions?
yeah.
Today we're exploring Sara Imari Walker's book, Life as No One Knows It.
Okay.
She's a physicist, but get this, she's not just looking at cells under a microscope.
Right.
She's trying to understand what life is on a fundamental level.
Yeah, it's a question that seems simple at first, right?
Right.
We all know a dog is alive and a rock isn't, but the more you think about it,
Yeah.
the trickier it gets.
Walker really pushes us to confront those assumptions.
Exactly.
Yeah.
I mean, even as kids, we can point to things and say that's alive,
Yeah.
but Walker throws some curveballs our way.
Oh, yeah.
What about parasites, like the zombie ant fungus?
Hmm.
It needs the ant to survive, so is it really self-sustaining, which is how we usually define life?
That's just one example.
Okay.
She also brings up how Darwinian evolution depends on reproduction.
Yeah.
But think about it.
Yeah.
What about someone who's past childbearing age or someone who's chosen not to have kids?
Right.
Are they not alive in that moment?
Yeah, interesting point. It highlights how our definitions get blurry at the edges.
And that's where Walker's argument gets really interesting.
Okay.
She says maybe we've been too focused on the parts of life, the cells, the DNA, the chemical reactions.
Yeah.
What if we need to zoom out and look for life's essence, the bigger picture?
It's like trying to understand a painting by analyzing the individual brushstrokes,
Right.
instead of stepping back to see the whole composition.
Yeah.
Walker argues that we need a new framework, a new physics, to really grasp what life is.
Okay, I'm intrigued. But where do we even begin with a new physics for life?
Well, Walker draws a fascinating parallel between the challenge of defining life
Okay.
and what philosophers call the hard problem of consciousness.
Right.
We can study the brain all we want, but how do we explain subjective experience? How do you measure the feeling of joy or the taste of chocolate?
It's like, I know my brain is firing neurons, but that doesn't explain what it's like to be me.
Exactly.
So what does this have to do with life?
Walker suggests there might be a similar hard problem. When it comes to matter itself, we know electrons have properties like mass and charge.
Right.
But those are really just descriptions of how they interact with our tools and experiments.
Yeah.
What are they really like when we're not observing them?
Wow.
It's kind of a mind-blowing thought, isn't it?
It is. It makes you wonder if our understanding of reality is way more limited than we realize. But if we can't pin down what matter is this, how can we even begin to define life?
That's where Walker's approach gets really unique.
Okay.
Instead of getting bogged down in definitions, she shifts the focus to what consciousness does.
Okay.
She points to philosopher Daniel Dennett's idea of the hard question. Can we measure the impact of consciousness on the world?
So it's less about what consciousness is as and more about what it allows us to do.
Exactly.
That's an interesting way to look at it.
And Walker takes this a step further,
Okay.
suggesting that consciousness might not be limited to individual brains. She proposes that we can see its effects in the collective minds of a species. Okay.
Leading to the creation of things that wouldn't exist otherwise.
Okay, I need an example here.
Sure.
What kind of things are we talking about?
Think about something like the laws of physics. Only life with its ability to observe, understand, and communicate
Right.
could have formulated those explanations. It's like consciousness at a collective level is leaving its mark on the universe. That's a pretty profound thought. It makes you realize how special life really is,
Yeah.
even with all its messiness and contradictions.
And this leads us to one of the central concepts in Walker's book,
Okay.
assembly theory.
Okay.
It's a new way to look at the physics of life, suggesting that objects are defined not just by their parts,
Okay.
but by the history of how they were put together.
Okay. Help me wrap my head around assembly theory. What do you mean by objects in this context? Are you talking about physical things or something more abstract?
We're talking about both.
Oh,
It
yeah.
could be a molecule, a planet, a poem, even an idea.
Okay.
Walker uses this great analogy with Legos. Imagine building a complex Lego structure.
Right.
The assembly index is basically the minimum number of steps it took to create it, reusing unique shapes you've already made along the way.
So the more complex the Lego creation, the higher its assembly index.
Exactly.
It's like a measure of how much information went into building it.
And here's where it gets really mind-bending.
Okay.
According to assembly theory, complex objects only exist in multiple copies because the process for making them has been selected to persist. Think about your Lego creation.
Go.
You were able to build it multiple times because you found a set of steps that worked and you remembered them.
It's like saying the history of how something was built is embedded in the object itself. Wait a minute, are you saying that information is a fundamental part of physics?
That's what Walker is proposing,
Ah.
and it has huge implications for how we understand life in the universe. But before we go down that rabbit hole, let's unpack some more of what assembly theory tells us. Think about it this way. You wouldn't look at a pile of random Lego bricks and assume they magically assembled themselves into that Millennium Falcon you built, right?
Of course not.
There's a story, a history embedded in that creation, and assembly theory says that's true for everything, from simple molecules to entire planets.
So it's not just about the building blocks themselves,
Yeah.
but the instructions, the blueprint, the information that guides the assembly process.
Right.
That changes how we view the universe, doesn't it?
It's a profound shift in perspective, and here's where it gets really interesting.
Okay.
According to assembly theory, the most alive thing on Earth isn't a biological organism.
Really?
It's the technosphere, all of humanity's technology.
Well, hold on. The technosphere is more alive than, say, a rainforest teeming with life.
Right.
How does that even make sense?
Think about the assembly history.
Yeah.
The technosphere has an incredibly long and complex chain of events that led to its creation. From the first tools to the internet, it's constantly evolving and creating new things.
Yeah.
It has an assembly index that dwarfs anything in the biological world.
So you're saying our technology isn't just an extension of us. It's a sign of life's evolution, maybe even the next stage of life itself.
Yeah.
That changes how I view my phone. But if we're seeing this incredible complexity emerging here on Earth,
Right.
what about out there in the vast universe?
That brings us to the search for alien life, which is another area where Walker challenges conventional thinking.
Okay.
She says it's not just about finding microbes on Mars or spaceships zipping around.
Right.
It's about recognizing the signatures of evolution,
Okay.
the fingerprints of information processing in the things we observe.
I remember that famous quote from Carl Sagan.
Yeah.
Extraordinary claims require extraordinary evidence.
Yeah.
Does Walker agree with that?
She does, but she also proposes an interesting twist.
Okay.
Walker argues that what we need are extraordinary explanations that connect even simple evidence to a deeper framework.
Okay.
Think about the 1996 discovery of Martian microbes in a meteorite.
Right.
It turned out to be a false alarm,
Yeah.
but it highlights how important it is to have a solid scientific foundation for our claims.
So not enough to just find something weird and shout aliens.
Right.
We need to be able to connect the dots to explain how that evidence fits into a bigger picture of life's origins and evolution.
Exactly. And that leads us to one of the biggest puzzles in the search for extraterrestrial life,
Okay.
the Fermi paradox.
Right.
If the universe is so vast and old and the conditions for life seem to exist elsewhere,
Yeah.
why haven't we found any aliens yet?
It's a question that's haunted me ever since I was a kid, looking up at the stars.
Yeah.
It just seems statistically impossible that we're alone, but then where is everyone?
Walker discusses a thought-provoking idea called the Great Filter, proposed by Robin Hanson.
Okay.
It suggests that there might be a barrier that most life hits, leading to extinction or making the origin of life itself incredibly rare.
Oh, wow.
Maybe it's some natural disaster, a technological hurdle, or even a self-inflicted catastrophe. Kind of a sobering thought, right?
Yeah. Not exactly the most optimistic outlook, but I have a feeling Walker isn't going to leave us wallowing in existential dread.
Right.
Does she offer any alternative perspectives?
She does. She challenges us to think beyond this bleak filter.
Right.
What if we're not seeing aliens because we're looking for the wrong things? Maybe our concept of what life could be is just too limited.
Okay.
Remember how assembly theory suggests that the technosphere is the most alive thing on Earth?
Right.
What if the emergence of advanced technology is actually the next stage in life's evolution?
Whoa, or you talk about some kind of technogenesis where life creates technologies that are themselves capable of understanding and shaping the universe.
It is, and it raises the question of whether we should be looking for signs of alien civilizations,
Oh, yeah.
not just biological life forms, but then how would we even recognize alien technology?
Like,
What if it's so advanced that it's indistinguishable from magic, as Arthur C. Clarke famously said?
that's like we need a whole new set of senses, a new way of perceiving reality to even detect these advanced civilizations.
Right.
Is Walker suggesting that such technologies of perception are possible?
She points out how throughout history, from the invention of the microscope to the development of telescopes,
Right.
we've been expanding our ability to see the universe.
Yeah.
What if alien civilizations have developed technologies of perception so far beyond our own that we're simply blind to them? It's like trying to explain the internet to someone living in the Middle Ages.
Wow.
They wouldn't even have the conceptual framework to grasp it.
So maybe the aliens aren't hiding. We just can't see them yet because our perception is limited.
Exactly.
But I'm still struggling with this idea of technology as the next stage of life.
Okay.
Isn't there a fundamental difference between biological organisms and machines?
That's a question that goes to the heart of what life is, and Walker suggests that the distinction between matter and information might not be as clear-cut as we think.
Okay.
Remember the hard problem of matter we talked about earlier?
Right.
What if what we perceive as material is actually just information playing out on a timescale we can grasp?
Are you saying that rocks and trees are just bundles of information? That sounds a bit out there.
Think about it this way. Things that exist on timescales much smaller than us, like atoms and molecules,
Right.
seem solid and real, but things that exist on timescales much larger than us, like human culture or even the universe itself, seem more abstract and informational. It's all about perspective.
Okay, I'm starting to see what you mean. It's like we're embedded in this vast web of information,
Uh-huh.
but we can only perceive a tiny sliver of it. But how does this relate to the idea of technology as a form of life?
Walker argues that we need to start thinking about life not just as biological organisms,
Yeah.
but as complex, evolving systems of information. Instead of looking for specific molecules or structures,
Right.
maybe we should be searching for signatures of information, processing those deep causal chains
Okay.
that have shaped the universe over billions of years.
So instead of searching for life as we know it,
Yeah.
we need to be open to life as we don't know it. Life that might manifest in ways we can't even imagine yet.
Right.
But how do we even begin to search for something so undefined?
That's where Walker's own research comes in. She's been working with chemist Lee Cronin on developing technologies
Okay.
that could help us explore these new frontiers of knowledge. Have you heard of the computer?
The computer, it rings a bell. Isn't it some kind of super advanced chemistry lab?
It's essentially a robot chemist that can automate the process of chemical synthesis
Right.
and explore the vast space of possible molecules. It's like a 3D printer for molecules,
Okay.
but with the potential to revolutionize our understanding of chemistry and biology.
So instead of just studying the molecules we find in nature, we can use the computer to create entirely new molecules, even those that might not exist on Earth.
Exactly. And this is crucial for the search for alien life.
Okay.
Remember, all life on Earth is based on the same basic biochemistry.
Right.
But there's no reason to believe that alien life would be the same. The computer lets us break out of that biochemical box and explore the truly alien possibilities.
It's like we're expanding the possibilities of life itself, going beyond the limitations of our own planet's biology. But what about the idea of consciousness and intelligence in non-biological systems? Is Walker addressing that as well?
She discusses the work of Mike Levin, a biologist who's been studying how information is stored and processed in living organisms, even those without brains. He works with planaria, those little flatworms that can regenerate their bodies.
Planaria. Okay. I'm not sure how flatworms fit into the search for alien intelligence, so help me out here.
Levin's research suggests that information might be stored and processed not just in brains, but also in bioelectric fields that exist throughout an organism's body. He's even been able to manipulate these bioelectric fields to create two-headed planaria. It's like reprogramming their bodies with electricity.
Whoa, that's straight out of science fiction. But what does this tell us about alien intelligence?
It suggests that intelligence might be much broader than we've traditionally thought.
Okay.
What if alien life forms have evolved ways of processing information that are completely different from our own based on principles we haven't even discovered yet?
Okay, my mind is officially blown. We're questioning the definition of life, the nature of matter and information, the limits of intelligence. I'm starting to feel like Alice tumbling down the rabbit hole.
That's the beauty of Walker's book. It takes us on this incredible journey through some of the most profound questions humanity has ever asked.
Right.
But don't worry, she doesn't just leave us lost in a sea of bewilderment.
Good.
She offers some thought-provoking ideas about how we might start to make sense of it all.
Okay, I'm all ears. How do we navigate this uncharted territory?
It really is a shift in thinking to consider computation at the heart of existence. Walker also addresses the practical challenges of actually building this new physics of information.
Right.
She says we'll need new technologies, new ways of thinking, and even new ways of collaborating.
It sounds like a monumental task. Do
Yeah.
we need to assemble some kind of scientific dream team to tackle this?
In a way, yes, Walker sees this challenge as an opportunity to break down the traditional barriers between scientific disciplines. We need physicists, chemists, biologists, computer scientists, even philosophers all working together.
It's like we need a new kind of renaissance, a fusion of ideas from different fields to crack this cosmic code.
That's a great way to put it. And Walker's book is kind of a rallying cry for this new scientific era. It's
Yeah.
not just a summary of facts, it's an invitation to join the search, to become part of this grand adventure of discovery.
And that's what we try to do here on the Deep Dive.
Yeah.
We're not just here to give you information. We want to spark your curiosity and get you thinking about the world in new ways.
Yeah, exactly. We've covered a lot of ground today, from the hard problem of matter to the technosphere as a form of life.
Yeah.
We've explored the Fermi paradox and the possibility of alien technologies beyond our comprehension. It's a lot to take in.
It really is. We've challenged a lot of assumptions about what life is, where it might exist, and what it might look like.
Mm.
What do you think, listener? What's resonating with you?
Walker leaves us with a final thought that I find particularly intriguing. She suggests that recognizing alien life might require recognizing ourselves in a new way.
Okay.
What if the first alien contact isn't out there,
Right.
but a realization of the deep connections between all forms of evolving complex systems right here on Earth?
So it's not about searching for little green men on distant planets, but recognizing the alien within ourselves,
Yeah.
the incredible complexity and interconnectedness of life in all its forms.
It's a beautiful and profound idea, and it suggests that the search for extraterrestrial life is ultimately a search for a deeper understanding of ourselves and our place in the universe.
That's a perfect note to end on. Thanks for diving deep with us today. If you're eager to explore more, we highly recommend checking out Sara Imari Walker's book, Life as No One Knows It. It's a mind-bending journey that will challenge your assumptions and leave you with a sense of wonder about the universe and our place in it. Until next time, keep exploring, keep questioning, and keep diving deep.